Hello, welcome back, and we're going to go ahead and wrap up what we started here with trying to find the volume of under this surface defined by f of x and y is equal to 24 minus x squared minus 3y squared on the region where x is between 0 and 3 and y is between 0 and 2. And this notation here is just another way to express those x and the y limits. So if you recall back our last video, we looked at the Reimman sum translation into an integral, and we ended up with this integral, this double integral, or iterated integral, if you will. Volume is equal to our integral of 24 minus x squared minus 3y squared dy dx, where our y ranged from 0 to 2 and our x limits were 0 and 3. So what we'll do is go ahead and go through the nuts and bolts of doing this by hand, and then we're going to do it in MATLAB and also show it in calc3D, and we're going to briefly discuss Fubini's theorem as it relates to this problem. So the process that we do this by hand is really similar to what you're familiar with Calc 2. So let's get started. Basically, the only really trick here is that we're going to evaluate this iterated integral from the inside out. So you notice that we have dy as sort of our inside differential here, and so we're going to first integrate that inside integral sort of in parentheses with respect to y. And when we're going to integrate with respect to y, it's a lot like when we took a partial derivative with respect to y, in that when we did that, recall that we did the standard differentiation process, but we treated our x variable as a constant when we differentiated, and we're going to do the same thing when we integrate with respect to y. We're going to treat that x variable as a constant also. So finding the antiderivative of these components of the function, that 24 is just a constant, so the antiderivative, we're just going to throw the y onto it, and that negative x squared, again, we're just treating that like a constant, so we're just going to throw a y onto that. And then using the inverse power rule, that negative 3y squared's antiderivative becomes negative y cubed. And we're going to go ahead and evaluate this at our limits 2 and 0. And of course, when we throw 0 in there, that's just going to all go to 0, so we just really have to plug in that 2. So we've got 24 times 2 minus x squared times 2 minus 2 cubed. And performing those arithmetic operations, we're left with that inside integral becoming 40 minus 2x squared. And now we've really just got a Calc 2 problem, because we've got an integral of this function with respect to x, integrated with respect to x for x is 0 to 3. So we just go through our basic integration process here, fundamental theorem of calculus part 2, and we get that antiderivative of our function being 40x minus 2/3 x cubed, evaluated at 3 and 0. And plugging everything in, we get 40 times 3 minus 2/3 times 3 cubed. And evaluating those operations, we arrive at our final answer of a volume of 102. And that's it. We did it. Pretty simple, but it gets a bit simpler if you do it in MATLAB. It's literally only 3 lines in MATLAB. But first, let's just check this out with calc3D, because if you recall back, we did a Reimman prism estimate there, and if we ratcheted up the number of prisms we used, we got something close to 102. So it looks like we're matching up, and of course that's always good to see that. Alright, so here we showed how to solve this double integral in Cartesian coordinates by hand and how to check it in calc3D. If you'd like to stay tuned for the next video, we'll discuss how to evaluate this a lot faster in MATLAB and also use MATLAB to show Fubini's theorem. But until then, take care.